So here we are at the summer assignment tutorial number 4, and this one's on density. And we can think of the definition for density as the amount of matter in a given amount of space. This is a physical property of matter. This is important to understand. In other words, for any pure substance, at a given temperature, I could look up its density because it is a physical property. It will not change as long as the temperature doesn't change. We can use density to identify certain pure substances, elements, and compounds. We could visualize density like this. Suppose that we have two identical volumes or spaces. These are supposed to be the same. Okay, and I know cartoons aren't perfect, so think of them as the same volume though. And this one is packed with particles like this. Okay, and this one is packed with the same type of particles, but like that. Because this one has more particles than this one does in the same amount of space, this substance is more dense, while this substance is less dense. So that's one way that you can visualize density, the density of two different objects. And there's a couple of different ways, and we'll do that in class. We'll do some more visualization at the particulate level. What's important to remember is that density is temperature dependent. I'm mixing my words right now. It's temperature dependent. It will change depending on temperature because the temperature of a substance can change its volume. Okay, ordinarily if we heat something up, its density is going to go down, and if we cool something down, its density is going to go up because we're changing its volume. What we have to remember though is the equation for density is mass divided by volume. It's the amount of matter, which is mass, in a given amount of space, which is volume. You should be able to algebraically manipulate this equation. So in other words, if I want to solve for mass, I can do so by multiplying both sides by volume. So if I multiply both sides by volume, then I end up with canceling out volume here and ending up with mass is volume times density. Therefore, I can also solve for volume, and I can solve for volume by dividing both sides by density here, and volume then would equal mass divided by density. So you should be able to manipulate this equation to solve for not only density but mass or volume as well. Suppose we want to find the density of mercury, the element mercury. Remember, density is a physical property, and we can do so. And by the way, let me just digress here for a moment. Density is temperature dependent, so a lot of times it'll be measured, for instance, at about 25 degrees Celsius, which is about room temperature, or sometimes it's measured at 0 degrees Celsius, which is the freezing point of water. And the density of water is something that hopefully you've known or learned before, but it's about 1 gram per milliliter. Now this is temperature dependent, so that's why I say about. It will vary from about 0.97, I think, to about 1.02 grams per milliliter, which is equal to 1 gram per centimeter cubed. Remember that a milliliter is equal to a gram, or is equal to a centimeter cubed. So our units of density can be in grams per milliliter or grams per centimeter cubed. They are the same. So the density of water is about 1. It's going to be really helpful for you to remember. So let's go back to our density of mercury problem. If the mass of mercury is 1.00 times 10 to the second grams. And the volume of mercury is 7.36 centimeters cubed. Then I can find my density. The density is going to be equal to 1.00 times 10 to the second grams divided by 7.36 centimeters cubed. And this is equal to 13.6 grams per centimeter cubed. I could also say it's also 13.6 grams per milliliter. They're equal. So we could use this density to identify the element mercury. So mercury at a constant temperature is always going to have this density. It is a physical property of mercury. Let's say I wanted to find the mass of 20 centimeters cubed of mercury. How would I do that? Okay, well, one way that we can do it is start out with our given quantity, which is 20 centimeters of mercury, and I want to find the mass. So I can use a conversion factor. So I want to find the mass, so that would be grams, and I want to get rid of centimeters cubed, so that goes in the denominator. So I have grams here, centimeters cubed here. Well, guess what? This is my conversion factor. What values am I going to put here? I'm going to put the density of mercury. The density of mercury we can actually use as a conversion factor. I know it's 13.6 grams per 1 centimeter cubed. So this is kind of cool. I'm using density as a conversion factor. It can be done. So centimeters cubed and centimeters cubed cancel out. I'm left with grams. So I have 20 centimeters cubed times 13.6. So 20 times 13.6 is equal to 272 grams of mercury. Okay? So this is just a real quick and dirty presentation on density. A couple of things you need to remember: that it is a physical property of matter. It's the amount of matter in a given amount of space. And you want to start getting familiar with visualizing density at the particulate level, something like this. You should be able to manipulate the density equation here to solve for either mass or volume. And you can also use density as a conversion factor. And you can do that in order to go here where I'm going from volume to mass. And I could also use that to go from mass to volume. I could work this backwards if I wanted. So if I had 272 grams of mercury and I wanted to know the volume, I would take my density, the density of mercury conversion factor, but it's flipped around. So if I'm going to volume, so centimeters cubed goes on the top, the unit I convert to goes on the top, the unit I want to cancel goes on the bottom. So in 1 centimeter cubed of mercury, I have 13.6 grams. Again, this is my density as a conversion factor. It's just been flipped around. So I have 272 divided by 13.6, which is 20 centimeters cubed of mercury. Okay, so that is density in a nutshell.